Welcome back to EGME-333 Fluid Mechanics. In this video, we are going to discuss the parallel axis theorem. So let's first begin by discussing the moment of inertia. So for a rigid body, the moment of inertia determines the torque needed for a desired angular acceleration about a rotational axis. To visualize the effect of the moment of inertia, let's consider four different objects that consist of the same mass and the same radius. And let's observe what happens to these four objects as they roll down an incline without slipping. From this example, the key observation that you should make is that although all four objects share the same mass and the same radius, the time for each object to reach the finish line varies. So the question becomes, what property about these objects is responsible for causing the variation in the rolling time? The answer is the moment of inertia, which depends on the body's mass distribution and the axis of rotation, where larger moments of inertia require more torque to change the body's rate of rotation. The moment of inertia is typically provided for the body's rotation about its centroidal axis. However, in practice, there are several cases where the body rotates about a different axis, x prime, which differs from its centroidal axis. In order to compute this body's moment of inertia, we can utilize the parallel axis theorem, which can be used to determine the moment of inertia about any axis. To do so, we use the following equation, where the new value for the moment of inertia, capital I sub x prime, is equal to the moment of inertia about the parallel axis through the object's center of mass, capital I sub x, plus the area of the shape, capital A, times d squared, where lowercase d represents the perpendicular distance between the x and x prime axis.